Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we are going to discuss comparators made up of op-amp. What are comparators? Comparators are electronic circuits which compares an input voltage along with a reference voltage. This reference voltage may be of DC. So sinusoidal input voltage will be compared with the reference voltage, and on comparison, an output is being generated. So if the input signal is fed to the non-inverting terminal of the op-amp, then the comparator is called as non-inverting comparator. So based on where we are feeding the input voltage, the output appears. If the input signal is fed to the inverting terminal, then the comparator is called as inverting comparator. So we are going to discuss one by one in the previous versions. Yes, I'll be drawing the diagram of a comparator. So the example I have taken here is a non-inverting comparator. So the input signal will be fed to the positive terminal of the op-amp. And a reference voltage, V reference. Yes, the output, the load resistor. The load resistor in the output, the voltage is obtained across the load resistor, and two diodes, D1 and D2. So this is the circuit diagram of a comparator plus VCC voltage and minus VE. So here the input voltage is fed to the positive terminal. At the same time, the VDC, that is the reference voltage, a DC voltage, is induced into the inverting terminal. So when our minus V reference is fed to a negative terminal of the op-amp, we'll just realize how the output be. So this is the input signal, Vin, and the reference voltage is a positive voltage. For example, this is the reference voltage positive. So how will the output of the comparator be? Is the comparator compares the input signal with the reference voltage. It's the output. Yes, I'm just drawing the vertical lines. Of the meeting points of the reference with respect to the input voltage. Yes, so I have projected the lines. Now when the input voltage is lesser than the V reference, then the output will be low. So it will be in minus Vsat. Low means it will be in minus Vsat. High means it will be in plus Vsat, which means the comparator swings between the two levels, minus Vsat and plus Vsat, and from plus Vsat to minus Vsat. depending on the input voltage and the reference voltage. If the reference voltage is greater than the input voltage, and also we need to confirm the input voltage where it is fed in. Since the input voltage is fed to the positive terminal, then the output voltage here will be at minus Vsat. At this point, the reference voltage is equal to the input voltage, and eventually the input voltage increases. The output will also increase and it will swing to plus Vsat and will maintain until the same value of plus Vsat until the V reference is lesser than the Vin. At the point where the V reference is lesser than Vin, a waveform is generated in such a manner, and hence this is the output which is generated by the comparator. So a sinusoidal wave is compared to a rectangular pulse wave in a comparator. Yes, by this way, the comparator compares the input signal along with the reference signal and the waveforms are generated. Another example with this is the input signal, and if the V reference is negative, how will the waveform be generated? This is T, this is T, this is the input voltage, this is the reference voltage. So, for example, if it is minus 1 volt, that's the input and output. How will the output be generated? This is the meeting point of the reference with respect to the input. So, the input voltage is fed to the positive terminal, but the reference voltage is minus 1 volt. Hence, the reference voltage is lesser than the input voltage, so the output will be high and it will maintain in this value. So until it reaches this value. So thereby here also the sinusoidal will be waveform is converted into an asymmetrical square waveform. So depending on where the input signal is fed in and the reference voltage, whether it is positive or negative, the output waveform swings from plus Vsat to minus Vsat or minus Vsat to plus Vsat until the meeting points of the input and the reference values changes again. The next comparator is inverting comparator. Yes, inverting comparator. In this, the input signal is fed to the inverting terminal of the op amp. Two diodes are for providing overlapping of the circuit. Plus VCC minus VE. The output voltage is collected across the load resistor. This is the circuit diagram of an inverting comparator. The input signal is fed to the inverting terminal of the op amp. When the input signal is compared with the reference signal, what happens? What kind of waveform is generated? That will try to plot it in a graph. So this is the input signal that is fed to the inverting terminal. And 180-degree phase shift will be there automatically. And if the reference voltage is positive, This is the reference voltage. This is the input voltage. V naught. So lines are the meeting points of the reference voltage and the input voltage are projected, and the output will swing either from plus Vset or minus Vset. So it depends on the input signal which is fed to the inverting input. Now here the V reference is greater than the input voltage, but the input signal is fed to the inverting terminal. So the output will be from plus Vset to minus Vset. Yes, this is the output which is generated by the comparator. Yes, so here the reference voltage is positive, input voltage is given here, but the input signal is fed to the inverting terminal of the op amp. So the general term for this is if the input voltage is lesser than the reference voltage, then the output will be at minus Vset. But here, since the input signal is fed to the inverting terminal, the output swings from plus Vset to minus Vset. These are the two basic comparators used for comparing reference voltage and an input voltage. We have another waveform generating circuit called Smith trigger circuit. Smith trigger circuit, based on the components connected in the circuit, the output is being generated. It swings from between the two saturation levels, plus Vset to minus Vset or minus Vset to plus Vset. I'll draw the simple diagram of Smith trigger. The input voltage is fed to the inverting terminal. Resistor R3, R1 and R2 resistors are connected here, and the output voltage is collected across the sixth terminal of the op amp. This Smith trigger circuit is called inverting Smith trigger because the input signal is fed to the inverting terminal. The Smith trigger generates an output which triggers between two saturation limits as sort of a comparator. But every time the input voltage exceeds the reference value, then it will be swinging between two levels, upper threshold voltage and minus lower threshold voltage. So here I assume this is the input signal V in, the reference voltage along with the resistors R1 and R2. The output itself swings from a higher potential to a lower potential. Yes, depending on the values initiated by the reference value that we have connected in the circuit. The output is generated in this manner. This is the output of a Smith trigger circuit. If a sine wave frequency f is equal to 1 by t is applied and symmetrical square waveform is obtained at the output, the vertical edge is shifted in phase from 0 to 0 crossover, where sine theta is equal to upper threshold value divided by Vm. So here, this is the upper threshold voltage and this is the lower threshold voltage. And Vm is the peak sinusoidal voltage. The same case, if the input is fed to the non-inverting Smith trigger, the input, then we'll assume that the output is positively saturated, that is at plus Vsat. This is fed back to the non-inverting input through the R1 resistor. This is a positive feedback. Now through Vin, though Vin is decreased, the output continues its positive saturation level unless and until the input becomes more negative than VLT. At lower threshold, the output changes in its state from positive saturation, that is from plus VSAT to negative saturation minus VSAT. It remains in negative saturation till the input voltage increases beyond its upper threshold value VUT. The voltage at point A is equal to In into R2. The input voltage is equal to V0 divided by R1, which is equal to plus VSAT divided by R1. The upper threshold voltage is equal to In into R2 is equal to R2 divided by R1 into plus VSAT, which is equal to VSAT into R2 divided by R1. And VLT is equal to R2 divided by R1 into minus VSAT is equal to minus VSAT into R2 divided by R1. So the hysteresis loop that is formed from the upper threshold voltage to the lower threshold voltage is the difference between the upper threshold voltage and the lower threshold voltage, which is equal to 2 times of VSAT into R2 by R1. Yes. So here, then what would be the differences between the two circuits we have discussed so far? The Smith trigger circuit and the comparator circuit. Yes. Feedback is used in a Smith trigger circuit, whereas no feedback is used in a comparator circuit. The op-amp is in a closed loop module, closed loop. The comparator, it's a open loop circuit. No false triggering is applied to the Smith trigger circuit. Here, false triggering is applied by means of giving a reference voltage. The signal levels are triggered to vary between the two saturation limits. Two different threshold voltages exist. What are the two threshold voltage? Upper threshold voltage and lower threshold voltage. Here we have plus or minus reference voltage. The next difference is hysteresis occurs in this Smith trigger circuit. No hysteresis in a comparator circuit. These are the differences between a Smith trigger circuit and a comparator circuit. So in today's video, we discussed about a comparator. The comparator is a circuit which compares the input voltage with the reference voltage. So we are providing the reference voltage and a sinusoidal input voltage is 10. So if the input signal is fed to the positive terminal of the op-amp, then the comparator is called non-inverting comparator. If the input signal is fed to the inverting terminal, then the comparator is called inverting comparator. So we discussed the reference voltage plus V reference. We have to get the output with plus V reference, minus V reference, and both with non-inverting amplifier and with negative amplifier. Then another circuit which behaves in a closed loop module triggers symmetrical or unsymmetrical waveforms, square waveforms from sinusoidal input. So here the circuit triggers and gives an output between two limits of upper threshold voltage and lower threshold voltage. The comparator triggers and gives output between two limits of upper plus Vsat and minus Vsat. This is a comparison of Smith trigger and comparator circuits. Thank you.